It is the 1940s, and the world is consumed by war. But out of the ashes of conflict come a massive boom in industry. Technology, manufacturing, and business management flourished from the 1940s to the 1960s. This revolution was led by innovations in business management practices. Pioneers like Peter F. Drucker, who some call the inventor of modern management, led the way in modernizing management practices, culminating in some of the greatest technical achievements in human history. Join us now as we examine one of these business management practices, known as the triple constraint. So what exactly is the triple constraint? Often illustrated as a triangle, the triple constraint represents the three main project constraints consisting of scope management, cost management, and time management. While most of today's modern business management concepts began emerging in the 40s and 50s, it wasn't until the early 1970s that a doctor by the name of Martin Barnes first referred to the concept of the triple constraint, which he called the project management triangle. No one knows exactly who originally created the concept of the triple constraint and the visual of the project management triangle, despite the fact that it has become such a widely used tool in business management. To fully appreciate the triple constraint, we must examine the individual pieces that make up this invaluable business tool and see what happens when managers fail to use it. First is the scope management constraint. Scope management is an essential part of keeping a project on task and under budget. In extreme cases, a failure or lack of scope management can lead to what is known as scope creep. Tech Republic defines scope creep as the expansion of a project outside of the planned objectives. Scope creep that is not quickly brought under control can destroy projects. One example is the electronic data systems debacle. In 1997, the Canadian government contracted two companies, Electronic Data Systems and SHL System House, to create a national firearm registration database. They set their budget at $119 million, assuring the government that it would be easily offset with $117 million in revenue from the gun registration fees. It just got worse from there. Electronic Data Systems failed to clearly define its scope and did not attempt any form of scope management. This failure resulted in over 1,000 changes to the project's scope, bringing the new total cost to a staggering $688 million, with an additional $300 million for support. By the time the project was killed in 2004, it had cost Canada well over $1 billion, while only generating around $140 million in revenue, earning the project the nickname the billion-dollar boondoggle. Next is the cost constraint. Controlling project costs is just as important as controlling the scope, as even if the scope is well managed, the cost can still grow out of hand. It is important for project managers to determine a project's ROI, or return on investment, to make sure the project's benefits will outweigh its growing costs as the project moves forward. The British government learned this lesson the hard way in what some experts call the greatest IT disaster in history. Originally planned in 2006 as a $9.5 billion overhaul to Britain's National Health Service database, the project, as of 2011, had cost the British government over $19 billion and was later scrapped that same year. The third constraint is time management. Time and cost are often interlinked in the project development cycle. This is why it is just as important to control project schedules as it is to control project costs. Time management means striking a balance between the project's scope and the project's costs. One way of doing this is by creating a work breakdown structure, also called the WBS. It helps break down and define the specific parts that make up the total work scope of the project. This allows managers to estimate project completion times. One way of estimating the total time from the WBS is using what is called the critical path method. The critical path is the shortest amount of time the main goals of a project can be completed, making it an essential part of time management within the triple constraint. Failing to manage the time constraint can have disastrous results for a project. Fox Meyer, a U.S. pharmaceutical company, learned this lesson the hard way when it attempted to automate its warehouses. In 1993, Fox Meyer was one of the largest drug distributors in the U.S., valued at over $5 billion. That same year, the company decided to undertake a massive $35 million project to overhaul its distribution system and automate its warehouses. The company failed to properly manage the time constraints and set an unrealistic 18-month timeline for a project that should have taken several years to implement. By 1996, it was clear that the project was a failure. The project had cost the company not only over $100 million, but it had also cost the company dearly in terms of trust and competition, and they ultimately filed for bankruptcy later that year. It should be clear by now that failing to utilize the triple constraint can cost a company dearly and doom projects right from the start. But what does the future hold for this management process? The future remains uncertain for the triple constraint. Even the Project Management Institute's renowned Project Body of Knowledge removed the triple constraint from their 2009 publication after relying on it for nearly 50 years. Despite the threats to the triple constraint's future, it still remains one of the most widely used models for project management and control. No one knows what will replace the triple constraint in the future. For now, it will be remembered as one of the most invaluable project management tools of the last 50 years. As Peter F. Drucker, the father of modern business management, once stated, knowledge has to be improved, challenged, and increased constantly, or it vanishes. And so too must the concept of the triple constraint improve, be challenged, and increase, or it too will soon vanish.